Yes.
Okay, great. So this is our third tutorial session, and we are at the point here where we are going to talk today about the team formation. Just to remind you, I'm Dr. Addison, and I am very happy to be here today to present to you with my mentors some of the aspects of moving forward in the competition and how do we do that in terms of forming teams and actually being able to participate and hopefully win some great prizes. So let's begin. I always like to remind persons about the challenge. Remember the time frame. It's from January 4th to March 1st, and we have been having a series of workshops, tutorial sessions, and webinars, some upcoming webinars as well to support, right? And the theme, of course, is adapting to climate change by improving the extreme weather forecast. Of course, you can go on the conference page to access the data set and the resources. And this is the point we're at now. For the last few weeks, for the last few Saturdays, we have been going through different aspects of the competition in terms of the Kaggle process, the datathon itself, how to navigate those pages, and for absolute beginners, how to actually understand the mechanism behind what data science is, and to be able to use some aspects of machine learning as well to be able to have a nice workflow towards actually analyzing the data set that we have at hand. So we are at the point today where we are at the team formation session. And of course, I'll remind you about the upcoming workshops, which will be very beneficial to support all of the beginner materials that we have been doing for the past few weeks in January. And these sessions are also available. You could go to our website, widstt.org, to view these sessions. I'll just remind you all that these are the upcoming talks and save the dates. Next week, Saturday, we have the data science overview and the WiDS Datathon challenge. Just to remind you, the time change is from 10:30 a.m. AST as the other events. And in particular, I would like to just point out that those free workshops that are coming up are actually very beneficial for both the participants and the mentors, because we have some of the international speakers who have been involved in the competition for the past few years, given us some of their insights, and they will be live. So it really would be of great use to you to be able to participate live in those sessions, to ask your questions and to see those demos go live. And of course, for those of you who have been with us for the past few weeks, you would see the progression from where we started with using the Python and the different tools and actually coming to the point where we are able to see how that works for the data set. The second workshop on the 11th of February will be based on data science methods at a glance. And we will also have someone from DeepNote. She was helpful in producing some of those tutorials that we spoke about last week that are lodged on the WiDS Datathon page. So she will also answer your questions based on some of the machine learning aspects. And then, of course, workshop 3. Workshop 3 is actually very, very beneficial to not only the competition, but for those of you who want to know what is next after training a machine learning model and getting all these insights, where do we go from here? And Sarah Ostermeyer, she also is involved heavily in this competition with the Arthur AI in the US. So she will come and do a really fruitful talk for us on that. And when we have some March regional events, which are a little less technical and a little more enjoyable in terms of the themes there. So you have all of those save the dates. Everything is available online for you at widstt.org. And of course, this is just a snapshot of the speakers in the different sessions. So feel free to peruse our page, and we have all the registration links on the website as well. So I remember I mentioned before the recap that we were talking about. So we went through understanding what data science is, the data science life cycle, the business aspect, the domain knowledge, and building all those different facets to actually understand now, how do we put these moving parts together to be able to analyze the data and get some insights. And we looked into the machine learning process last week in a really more detailed way. We had our mentors go through some really nice notebooks for you to kind of show you that process with the exploratory data analysis and the different tools and the different means that we use to be able to get our data into a form that is much more usable and user-friendly, to be able to get insights to learn, predict, and improve using machine learning. And of course, to these teams, I think at this point, you're probably thinking, okay, so after all of this, where are we in terms of what we actually trying to achieve? So at this point, we're really happy to have you all on board with us. We want to actually form teams. Now, I will tell you that even though we will be forming teams, remember the teams themselves have stipulations of up to 4 persons, as we mentioned previously. At least half must be female. But of course, what we will do in the spirit of what we're trying to have in this community is to actually have everyone work together. But you will be on your assigned teams for the competition because you will compete. Of course, remember the skills for the teammates and the mentors that we would expect you all to have. Some of you will be absolute beginners. So at a particular segment today, we will have you in a breakout room and you will actually let us know what are your specific skills that you could contribute, even self as research variables, if you're an absolute beginner, or if you're somebody who's more intermediate to advanced, and you could actually provide more of a machine learning type of exposure for us, for our teams, then you could let us know. The benefits, well, of course, the global prizes from Kaggle are about 6,000 US in terms of the different teams. You can go on the webpage to see the different stipulations with respect to the teams and the prizes. I think you'll probably, for those of you who are interested in local prizes that will be offered from our group, we have 2,000 US in cash prizes and more. So you'll also be getting certificates as well. The top 3 teams, we will let you all know what are the different segmentations of the prizes in terms of the cash prizes. And of course, you know, all of these things are really great for your for impact and of course the networking, etc. So at this point, I just want to remind you all the process for any of those of you who are new, who came in at any point later than when we started in the beginning of January, that you should view the challenge, register for the challenge. So from the poll that I asked originally, if you haven't registered yet, remember you have to officially register at this website, not the original participant interest form that you signed up for. That's for our group purposes, but for the global website, you have to sign up here. Of course, if you need any information, feel free to visit our website and of course, contact us via email. So at this point, just to let you know the flow of today's session, it's an open session. And what I have done is I have brought on board to be our first speaker, one of the previous WiDS teammates of mine. I could speak for a while about his accolades in terms of academics and professionally. I'm very, very happy to have him on board today to give participants and the mentors a little bit of a context and open conversation about what we encountered in our experience last year, being on a team and how we dealt with meetings. Because remember, it's not just the skills, it's also the team building, it's also the communication aspect, being able to meet up and really assess what needs to be done with the data set, which is, I think, the point that I have you all at, where you need to understand what you would need to bring to the table in terms of a team. So I'm just going to stop sharing my screen now, and I'm going to ask Mr. Kevin Rajaram. So he has been a data scientist for many years, and Kevin is also doing his PhD in computer science. So I would like to ask Kevin if he would like to give you all a few words about the experience we had on the team last year. So Kevin, you could take the floor now and take it away.
Sure, no problem. Thank you, Letitia, and good morning, everyone. Yeah, so the WiDS experience, it's really, I would say it's a fun challenge, to be honest, and it's really meaningful. I guess at the heart of it is that you have to take away the theme, right, before you take away the actual data challenge, which is women in data science. Let that be like one of the central aspects of this. Traditionally, computer sciences and STEM has been a male-dominated field, and as we progress into 2022, 2023, with all of the aspects of diversity, equity, and inclusion, this would have been a central theme for many areas. So not only in academia, but also in the professional or private sector, right, in corporate entities. So this has been a central theme. So when we actually began looking at WiDS, Letitia would have approached me simply because I was involved in data science, but also because we would have collaborated on previous things. Actually, Letitia used to be a lecturer of mine when I was doing my undergraduate degree. So hopefully you guys don't think she's too old, but yeah, she was actually
Probably not.
so she was actually a lecturer of mine, and I finished my undergraduate some years now. So yeah, we've been in the area for quite some time, and I would say holistically, I've been involved in data services for the past 10 years, right? So end to end, and with my collective experience, my background being in mathematics and statistics, over the years, I would have gotten more involved into computer sciences and data science specifically. So when this challenge presented itself, it seemed like a good opportunity to, put things in perspective with end-to-end application, right? Which is something that I think is of utmost importance when you're forming your teams, right? So that would be my first point to you guys. Make sure you form a team that is well balanced. Because you're going to have, everyone would have different strengths and that you can use to leverage off of, while having the opportunity to build on weaknesses that you'd learn from each other, right? So within our area, I would consider myself a generalist, but like I do have experience with building machine learning algorithms and feature engineering, right? But within our team, we had people who were really good at research, who could actually dedicated time to research in the literature. Letitia would have been really good on our team for the probability and statistics aspect of it, like actually creating the summary statistics and doing the exploratory data analysis. And what actually was beneficial to other people on the team who did not have, I would say, like the subject matter expertise, is that they were able to contribute in terms of research, pulling together relevant information needed to complete the challenge, even accountability. I would say that, and definitely Letitia really thrived in this area when I participated on that team, is that we had someone who was a dedicated team lead. So, somebody doesn't have to be like, the best in machine learning to be the team leader, right? You could just actually have a really good leader that is willing to make sure everyone is accountable, that people are uploading algorithms, and that that in itself is a really useful thing, right, for a team to have a team lead that holds everyone else accountable. So I would say factor those things into the building of your team in general. Like, make sure you have a well-balanced team, that those responsibilities are clear from the onset, that just because someone has like a very relevant skill set, that doesn't make them the natural leader. Also be able to, I would say from the onset, be very transparent about your other responsibilities, because WiDS is very demanding, but make sure that you are able to prioritize it while juggling while handling your other responsibilities, whether it be schoolwork, family, and so on, right? You want to make sure that you have time that you can set aside to be able to be active in the competition. So I would say make sure you can factor those things into the competition. I think you guys would have a 2-month window, and actually we're closing into the end of January, right? So I think, when does the competition end? Sometime in March, correct, Letitia?
Yes, it's March 1st is the deadline.
Right.
So technically a month,
so
a little less than, yeah.
Yeah, so it's a tight window you guys will want to do. And while it is fun in terms of the experience, you will get valuable experience. I was competitive. I am a competitive person, so try to factor that into it's a competition, and there's real reward at the end of it, both at the local level that Letitia and the mentors and ambassadors are promoting, but also on the competition itself. It's really meaningful. And if you guys do have an interest in the area, having yourself on as a top finisher in a Kaggle competition is really, really prestigious in the world of data science, right? I believe when we finished in the top 40%, and to me that was quite a really reputable thing for a small, I would say a novice team on a global scale, right? We were able to finish in the top 40% of all participants, and I think when we participated, it had over 1,100 participants, right? So to me, that was really, really good. That actually shows up on my CV. And this is not the only Kaggle competition that I participated in, but you know, it's very noteworthy, especially with what I underscored in the beginning, with it being a DEI type of initiative. You know, you're actually participating, you're promoting women in data science. And I'm not saying that I'm using it as leverage to get a job and say I'm a DEI person, but I actually valued it. I actually enjoyed working with the women, collaborating, actually hearing their perspectives, not only as data scientists, but actually as women in industry or women in academia. So yeah, that was a really useful thing for me. Then, you know, there's also the application side of things, which I would say was really, really useful. We had different metrics. Well, we had one particular metric that we needed to optimize on. And yeah, it was really fun, I guess, to try to get the best possible model, the best possible answers to upload. It was always very heart-wrenching when, you know, you uploaded it and, you know, your results weren't good, but it gave you perspective to go back and possible things that you can try and how to look at it. So I would say, you know, take the challenge for what it is. It's a very fun thing, but, you know, there's also the competitive side that I would say, you know, it's useful. Competition improves you, right? And everyone wants to do well. And I think that you guys, now that you have people who are mentoring and you have all these opportunities at your disposal, you actually stand a really good chance at having a competitive edge relative to when we started, right? It was really just us and research and reading, and it was more of a grueling exercise. I definitely didn't have a mentor call like how Letitia, you know, is kind of advocating and being an ambassador for this thing. We didn't have that. We just had the general WiDS competition. So I would say take advantage of the resources that you guys are being given. And use that to your advantage. And yeah, that's what I would say about generally the competition. And obviously use the experience to build on soft skills as well, right? I mean, use the opportunity to get to know people on a personal level. I mean, coming out of it, I would have formed like really meaningful relationships with the participants, right? We actually went on to participate in other challenges. We've been able to do research together. Like Letitia and I even continued working on other research in wider areas that led to things like us participating in conferences and potentially working on publications together. So, you know, I would say use those things to continue to grow your network, to continue to build on soft skills, collaboration, team spirit, leadership, and then also your technical skills, right? Learn from the people that, you know, in your teams or in the overall group, in the overall mentorship, learn from those things. And they will serve you well, whether you choose to stay in academia or enter the professional or corporate realm. Those things always continue to serve well. So that would be my advice in terms of the general theme of where this thing can lead. Right. So I would say definitely it's an enjoyable but very rewarding challenge to be a part of.
Wow. Thank you, Kevin. That has been a very, very comprehensive and really concise overview of everything that you know, all the experiences we had over time being in this competition. And I would say that one of the central things that we wanted really to achieve is to allow you all to see that it's just more than the challenge, you know, is really that building that, as he said, the community aspect, the team aspect. I mean, we would like to promote women as we are doing here, but in that promotion, you realize that we really do need to work together with everyone. Everyone has a different skill set. And as Kevin mentioned, you know, we want you all to build on your skills and what you are good at and what you feel confident in, and what you don't feel confident in, we're here to help. Some things may feel a little more intimidating than others, and we understand that too. I think, as he mentioned too, you know, to be part of a mentorship group and to have this, we didn't have that when we were going through our undergraduate degrees, when we were going through our postgraduate degrees and all these types of things. So it's really like we want to give back. Kevin has agreed to consult with us anytime we need any sort of consultations, or mentors will also consult with him as well. And I think that I'm hoping that you all will find the experience fruitful. And I mean, I know, as he said, it's a competition. So some of you will be competitive, and that's what we want. But we want you all to all work together and to really just, really do some meaningful work. And of course, have your skill sets improved as well and enhanced in the experience. So Kevin, we're really, really happy to hear your feedback. And we'll have Kevin come back in a little while to give some more technical aspects to the persons who already raring to go with the competition. But right now I'm going to pass you on to Nicholas, our mentor from last week. I think a lot of you would remember Nicholas did a really, really nice exploratory data analysis tutorial to kind of give you a head start on the data set and actually understanding what we need to do before we jump into the machine learning. So Nicholas is coming back in to give you all some insights with a notebook. I think we'll share the notebook in the chat. So Rihanna is going to share the notebook with you in the chat, and Nicholas will. Nicholas, I hand the floor to you so you could give them an overview. This notebook actually contains the climate data set, so you'll actually see what's happening in here, and then in a little bit we'll put you all into some breakout rooms to get to know each other. So Nicholas, I'll hand over to you.
All right, thank you for that. Everybody can hear me well?
Yes, we can.
Okay, I'll share the link in the chat. Let me know if everybody could get access to it and if they can view it. All right, everybody have access and be able to click on the link and view it. All right.
Yes, we can.
All right, nice. So with this, we're going to be able to create a copy so we can run the cells on our own collaboratory notebook. So what we're going to do first is click on the file and then save a copy in Drive. It'll take couple seconds and it will direct you to a new tab. And when it's finished loading, it'll be called copy of WiDS Kaggle competition 2023. And now that you have your own copy in your drive, you'll be able to run the cells. And initially they have this NVIDIA Rapids library. We won't be going through this too much, but you can go through on your own. Here are the resources for the Rapid AI that you can go through on your own and use those tutorials to go through the data and do an exploratory data analysis on the data. So everybody have a copy of the notebook as yet? All right,
so remember from last week that yes, copy the notebook one time, right? So make a copy of it and save it.
All right, I already connected my drive, but as you scroll down in the activity optional, there are three ways to load the CSV file into the collab. This is the resource first. When you click on it, it will bring you to this article. I'll show you three different ways. This way here, it provides a button for you to upload it onto the notebook itself, but this may take some time. So we will go with this route instead, where we will run this cell. And because I already did it, it's already mounted, but for you, there will be a pop-up asking you to grant permissions. You grant the permissions. And when you do, this drive folder on the left-hand side will pop up for you. So just give it a couple minutes so you all can do that and let me know when you all have reached this point. And the reason we're doing this is because we will have the trained data sets on our Google Drive, and then we will be accessing it from there. if you don't have the train data set on your Google Drive, just let me know and I'll show you how to upload it to the Google Drive.
Any problems so far? Anybody needs any clarification? Remember, these are some of the steps that he would have done last week. So we just kind of doing a little bit of a short overview of the similar steps with the climate data sets. And if you have any problems running it on your end, let us know.
All right, at 11:32, I will continue on. If there's anybody that is lost or behind, just let me know in the chat and I'll help you get up to speed. All right. If there's anybody that's still doing it and they need me to assist them with uploading it or connecting it, I'll be just shoot me a message in the chat and I'll be happy to help. So after you have the data inside Google Drive and you've connected your Google Drive to the Google Colab, this cell here will be accessing the print data, the test, and the sample solution, and assigning it to these three variables that we're going to use inside the notebook. So we'll run that cell to load the data into those variables. All right, great. And there were a couple discussions on the Kaggle discussion tab here, where the data set is quite large, and there were some discussions about reducing the memory usage of it. That's what this function is for. On the discussion forum, there were screenshots of it, so it'll be kind of difficult to recreate on your own. So here you can just copy and paste it, or you can just run it from here to create the function. And then you will need to pass in the variable for the train data set. So when you run here, this cell, you take a couple of seconds and it will show you how much was decreased. 50.1% reduction, which is good. And next we will look at how the data is structured. So here we'll be using the shape to display the amount of rows and columns in a data set. And when you run that, you'll see that there are 375,734 rows and 246 columns. It's quite a lot. And we can get a brief overview of the first 5 rows. And as before, we can add an integer value inside of here to get us the amount of rows that we want. If we put 10, we'll be able to get 10. And looking at the data here, we can see there's a lot, but more specifically the start date, because on the competition overview, sorry, any data instead, we want to predict the arithmetic mean of the maximum minimum temperature over the next 14 days. So the start date will be an important column or feature first that we want to use. Right now it's formatted not a good format for us to do some analysis on it. So you need to, as we go on, change it to a better format. And the next cell we will run that will describe the data to provide a description of the count, mean, standard, deviation, min for the different columns that have integer and float data in it. And here we'll be converting the start date to datetime type using the datetime library from Python. You would have this library imported at the beginning from activity 1, from right here. So when we run the cell, we will access the start date from the dataset, and we will use the pandas library, a function called toDatetime, to change it to datetime format. So take a couple seconds because we're changing all the rows. And then when we can run head again, you can see that it changed to this format, from this format. And you can see it for the entire data set, the beginning and the end. Now we want to check for some missing values. We can use this is null and dot sum to get the amount of missing values for each column inside of the data set. And as you can see, there's a lot of columns, so we're not seeing all of it. You can also use the .isAny on the data set itself with the .any to see as well. But as we're doing this, we're not seeing any nulls, but we can use this next cell, and it shows us that there are 1, 2, 3, 4, 5, 6, 7, 8, at least 8 columns that wasn't displayed here that had empty rows, empty values. So we will need to go through the data, and as we're going through the exploratory data analysis, we will need to find out if these are important for us and what we're going to do with it. The next step is questioning the data set. So here we can use this for loop to find out the different columns inside of the data set. If you want, you can use this. You don't need to use this for now, but if you want, this will be helpful for you to see the different columns. And because the data set is so large, we should be able to get subsets of the data set. So here on this cell, we're getting the start date, the contest target column, the latitude, longitude, and this temperature from NASA. And get the exact name for it, sorry. And you can use any data tab to get the names of the variables or the columns that they have. And NMME is the North American Multi-Model Ensemble. It gives a nice description of what it is here. And so this is the first, the prefix is the North American Multi-Model, and then this is from NASA. And as we get the subset, we assign it a new variable, and you can see we just got this these 5 columns alone. So doing this would allow us to target different columns inside data sets instead of working on all 246 columns. And then we will want to be reshaping from wide form data to long form data. In long form data, we'll be able to visualize it better and get different inferences from the graphs. So what is wide form data? It's a format in which each row represents a single observation and each column represents different variables. And the format is typically multiple columns for each variable, with each column representing a different value category. And it's also known as untidy data. When we want to graph from a data set or visualize a data set, we want it to be tidy. And this will be the long form data. This has 1 column for each variable and 1 column for the value of each variable. It's also known as tidy data. And is a format in which each row represents a single observation, and each column represents a different variable. And in this format, there's one column for each variable and one column for the value of each variable. This allows for easy analysis and visualization of the data. So to change it from wide form to long form, there's a function called melt, where we can provide the start date. So we want to target the start date. We'll create a column called variable, and then a column called value. So we run this cell. It will create this variable for us to use. And then in here, we're going to filter out latitude and longitude because there are some rows that have 0. And I mean, when we run this, you'll be able to get this format where there's a start date, the column name, and then the value associated with that column. And it goes all the way down to the NASA North American multi-model, and then the contest target variable. And now we can start targeting the data inside of here. With this next cell where we could use the lock that is part of the pandas data frame. And here we are targeting the start date that is equal to 2014, 39th month, and the second date. September the 2nd, 24th. And these are all the values that was recorded. And next we'll be grouping data. So the data set grouped by a certain criteria. We'll be grouping by latitude and longitude by the week, and the week starts on a Sunday. So we'll be using the group by. You can use the group by function. And as here we want to use the latitude, the longitude, and then we want to use the grouper function from the pandas library. And we're using the key for the start date, and the frequency tells the function, tells the function by week, by month, or by day. So W is for week, capital M is for month, and capital D is for day. So after we run this, we'll be able to do feature engineering for the start date, turning into integer representation. Because it'll be difficult to do an analysis on this format, we'll be able to use this to get an integer representation of it. And here we begin the earliest date. And then changing that to the days. And after we run that cell, we'll be able to run the second cell to display the start date in latitude, longitude, the column name that we wanted, and the other column name. This will be an example of group by for the month. So as you can see here, it's scroll down 24 rows compared to the 53,970. So as you group by different categories, will be less or more rows. And we change it to detail so we could see day instead of, and there's a lot more rows instead of months. Now the analysis of the data. So some possible steps we can take, there are a lot more. These are just some. They explore the distribution of the target variable and examining the patterns in temperature and precipitation. So this is the column that we want to print out. So it's a single column. Before they had the 246. If we want to view each column singularly, we can use this code cell and just change this string here So let's say this one. As an example, we want to use that instead of seeing the contest values. And it prints out the single column first. Next, we'll be plotting a line graph of the start date in relation to the contest variable from before. So we'll be using the C1 library to plot the line plot, but we will also be using matplotlib to change the dimensions of the graph itself. If it changes to 15 and 10, it will get a lot bigger. And it may take some time because there's a lot of data for it to graph. And while it's doing that, this axis will be added into the function by calling ax, which is the parameter, and it's equal to the ax you defined out here. So it makes the graph bigger to visualize better. And as you can see, the temperature from 2014 started at around 18, 19. A nice guess. As you can see, it started to dip and then increase and then dip and then increase. And then at the end of 2016, you can see it's almost close to what it was at 2014. The next one we could graph is the sea ice concentration over time. Now there are different columns for the sea ice concentration. We're using 2010 and 10. Sorry, just 1 second. Yeah. And then we're graphing the long form data here to get a better understanding of the start date along with these two variables. So from the long form data that was find it here, right here, we have these two columns that we wanted to compare. And these are the two variables that we're comparing here. So we could change those two columns. Let's say the wind 2010, 11. One second. Right here. So instead of the contest, yeah. Yeah, instead of the contest, you'll be doing new wind and then the temperature from NASA. So you run it again. And then you'll go back down here and run this cell. It takes some time. And that will be the end of this section. Is there anybody that wasn't able to run these cells or follow along? And as you're doing your own exploratory data analysis, you'll be able to change the values in here to the different values that we want.
Anyone has any questions for Nicholas? Nicholas, that's really very, 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 very concise in terms of all the codings that you have put in there for them to help. I know it's a bit technical for some of you, but I would let you know that this aspect, this framework here is really flexible because, as he mentioned, you can change some of the variables just to see what's happening. And I always tell people, just from my own personal experience, do not be afraid to just play around with the data set on your own, just to see what's happening. Nobody's watching to see if you make mistakes, right? And just knowing coding, you're going to get some errors at some point in time to get accustomed to the fact that you'll just be doing a lot of exploring on your own as well. And that will actually build your confidence. Not everyone will want to keep on the technical path, and that's fine. But do you all have any questions for Nicholas? Anything, any problems? And feel free, even if you don't want to say it now, remember, you all could email us or let us know in the Slack channel personally. You can actually message Nicholas personally in the Slack channel, as well as our other mentors, if you have any specific questions. Is there anything else, Nicholas, before we just jump in, just bring Kevin on just to give a little bit of context to the machine learning aspects? Anything else on the?
Yeah, just one quick thing I wanted to fix
Yes.
the change from before.
Sure.
You can change in these values here first, and then you'll be able to change the values here, and then you'll be able to graph it properly from the last line. And that was it. So you change the values from those two positions first, and then you could see the updated graph. Yeah, that was it.
Okay, great. Thank you very much, Nicholas. So remember, if you all want to use this as your homework for the next few days and weeks, to kind of get yourselves acclimatized with how the exploratory part works, feel free to do so. I just want to go from a little more of the beginner aspect, just to bring Kevin back on board before we jump into some breakout rooms where you all will get to know each other and kind of organize the skill sets you all have in a form. So Kevin, and Navin has also said something in the chat. So Shankar mentioned that you can Google. Remember, we wouldn't remember these routines offhand. Please feel free to Google. Google is your friend. Navin also mentioned Stack Overflow as well. So you have all these really great resources and communities there for you if you need to, have that support. Before we go into the breakout session, just to kind of get everyone getting to know each other, I just wanted Kevin to just come back on just to give some of the persons who already have the more intermediate knowledge, some aspects in terms of where we move from the exploratory into the machine learning. We spoke about regression last week, but I think Kevin will give you all some context in terms of what sorts of methods you can use from this point onwards. So Kevin, I'll pass back to you.
Sure. Thanks, Letitia. And Nicholas, really good workbook in terms of looking at the data. I would say my suggestions are in terms of approaching this is really become intimate with the data. That's always a good place to start, immersing yourself in the actual problem. So you guys have to put on your climate change hats. And if you don't have a climate change hat, I would say just kind of familiarize yourself with key concepts, right? One of the challenges that people often have is that they look at this from a purely numeric standpoint, and there is a lot of merit to understanding the domain aspect of it. So looking at that there, I saw that the sea ice concentration just quickly didn't really decrease, but yet on the news, you hear that, sea ice concentration levels should be going up because ice caps are melting. And so we'd expect that between 2014 to 2022, there would be some increase. Now, obviously, that was just a small subsection that Nicholas would have looked at there, right? So those are some things that I would suggest that you kind of immerse yourself with that lens on and question the data. When you question the data, you're able to derive a lot of meaningful insights that will really enhance when you start to go into the machine learning aspect of it. So that's tip number one. I would also say really draw on things that come from statistical theory, which is understanding the relationships between variables. So just looking at things very with a narrow scope will probably not serve you well in terms of building an accurate model. And so that we are very clear on terminology. Now we're looking at accuracy, right? I think that's the model you guys have to optimize on. So we make sure that you are familiar with the KPI, the key metric you are trying to optimize on. Accuracy being the total number of accurate predictions over the total number of records predicted, right? So there are other important metrics when you start to build machine learning models like precision and F1 scores, and then your overall confusion matrix that gives those things as outputs, right? So, and I would say, and recall, sorry, a sensitivity. So there are different things that you probably would have met in statistical theory, and even in some of the computer sciences courses, and those things serve you well in terms of what you are trying to land at, right? And that will determine how you optimize both your model and your hyperparameters when you are building the actual machine learning algorithms. That being said, there are some useful statistical techniques that I would say, looking at like correlation heat maps, for example, both linear and nonlinear correlation heat maps or correlation values kind of tell you which variables are strongly correlated. And so because you have the output on your trained data set, you can start to see what is strongly correlated in a linear and nonlinear way with that variable. So I would say that's a good place to start as well in terms of your modeling. Before the call started, I was mentioning to Shankar that there are some things that you can do to start minimizing the amount of variables that you train your model on, such as like stepwise regression, where you do backward elimination, where you start with all your variables to give you one of the measures of variance, which is R squared, that you can start doing backward elimination just as a method of starting to see which variables are important. Your correlation matrix will also tell you which variables are somewhat important or strongly correlated to your output variable or your target variable. So there's lots of things that you can do. And I would say, like, keep all of these things collectively in the back of your mind, because all of them could probably work together to giving you an optimal output, right? So even before you start building your machine learning algorithm, you'd have a good sense of which variables work well together, which ones don't really seem to add much value, which ones you could probably discard because chances are it's not going to add much value. And even when you are finished with your variable, with your model predictions, or you can always go back and test feature importance again, right? So I would say at every point of this thing, just keep testing variable importance, pre-building, post-building, always test your variable importance. That's what's ultimately going to determine your level of accuracy. There are other things that you have to check for, not only missing values, but anomalistic values as well, right? Outliers. So which variables misbehave, even if it's highly correlated, which ones misbehave or strongly negatively correlated. You're looking for bad behaving variables as well, right? With bad behaving values as well. So you can know if to delete those records from your model building and account for it, why you deleted it, because it's really skewing the results, right? Don't go into over deletion, even though you have many rows. When you delete a record, you ultimately influence how the model outcome looks like on your test data, right? Which is what your sample solutions file would ultimately look like. So I would say last year, one of our teammates, he over deleted and he got really good results. I don't know if you remember that, Letitia, when Ken had gotten some really, really amazing results.
Yes.
And then I would say be overly cautious when you start to get those kinds of results because of deletion of anomalistic values. He deleted too much. And so he got a false representative of the world, right? So you have to also think about data as this is real world data. And when you delete too much of things, you change the perspective of the world. So when you actually test on it, you're going to get a false sense of perfection, which is not actually going to run well when you validate your model. So don't delete too much, but also delete things that are really, really skewing your data. I would always say never go beyond like 10% of data deletion. So if you delete more than 10% of your records, you're probably going to wind up with some over perfected data values, as in it's overly perfect. And if you get anomalistic data in your test data, your model wouldn't know how to deal with it, right? So there is some merit to having anomalistic values or outliers, but sometimes when it's really skewing your results, I would say remove those things. So those are, I know that's a lot of things to keep in perspective, but I mean, any good literature would tell you like these steps in sequence, right? They would always tell you in your exploratory data analysis, look at missing values and look at imputation techniques. They'd also tell you how to deal with anomalies or outliers, how to remove them, if to remove them. And you realize this is all even before you even start building machine learning algorithms, right? Which variables are important to include, how to make your data frame more concise by either using some sort of dimension reduction technique, PCA being one of the most popular ones, or some sort of variable elimination process like stepwise regression and things like that. So we didn't even get into the actual building of the models yet, but all of these things will ultimately influence the outcomes of your models. Now, you guys have a regression outcome type scenario, and I would say explore all of the popular algorithms and then start boosting them and then start ensembling them. Take the ones that work really well together and boost and ensemble them. And that should give you really good results when you start getting good, accurate results, right? And then I would also say, as soon as you can, which is really important, start validating your results on Kaggle so that you have a benchmark to start with. It will, one, let you know where you are relative to everyone else, and one, it will let you know what you have to improve on for accuracy. It gives you a good benchmark. There's no point in just trying to get the best results to start with. Just start with something. A trick that I've done in the past is I've just uploaded the sample solutions data just to get myself there, just to see what it was, what those results are, and start benchmarking against that, right? And you could always use like simple techniques, like when you get your output, compare it to the best results that you've produced, and you could just pretty much subtract it. Is your results getting better or closer to what you expected, right? So those are little tips and tricks you can do to optimize your results. Look at, if you are using models with hyperparameters, you can use techniques like grid search for optimizing the best set of parameter tuning, right? So you can use techniques like that. So when you actually get into your modeling, I would say make sure you look at research for hyperparameter tuning, right? Make sure that your parameters are actually giving you the best possible results. If you have different types of regression models, make sure like you're using the right one, whether it be polynomial or RGBF or whichever one, sigmoid, kernels. Make sure that those things are properly tuned so that it's giving you the best possible algorithms. And like I said, make sure you use multiple algorithms just to see which one works better with your data set. Obviously, different data sets like some algorithms work better with different data sets, right? So some algorithms work better with smaller data frames, and others work better with more data. The more data you feed it, like neural networks, for example. So those would be some of the things that I say. Simple is always good, a good place to start. Don't just jump right into building like ANNs just because you have GPUs at your disposal. If you guys are working with TT Lab, for example, I don't think you would need it, but just in case, for processing of time. So if you do things to optimize your data frames, you wouldn't even really need to get into that realm of things, right? Because you're using static data, you're not getting new world data added to your data sets. So these are some things to factor into the complexity of your models. And I would say, yeah, definitely check online resources, right? Kaggle has published tons of stuff on these kinds of problems. Use your discussion boards within Kaggle. You would see what other people are doing. They publish their notebooks as well. Interact with that community. You'll meet a lot of people who are experts in different areas. So look at those things closely. Stack Overflow, just regular Google searches. Google Scholar, you could actually see like research literature around. I'm sure there's actual publications around this area of study right now, climate change. There's probably tons of them, and people have looked at these problems. So it gives you a perspective of what has been done, what could be done, things that they've already identified as problems, even with their algorithms or the way that they view the problem to start with, right? You're not starting from scratch, and I would just kind of like to end on that theme. You really aren't starting from scratch. This is nothing that you are doing is going to be novel, and if you are doing something novel, then you should be doing a PhD. And if you
Agreed.
and that's where it could lead to, right? When you start having like novel ideas around these problems, you can start looking at advancing your degrees or your mode of research or your publication aspect. So yeah, that's the note I wanted to end on. I will send Letitia some documentation and some sample code as the things that you guys can look at when you do begin your machine learning modeling, so that it helps in that regard. And yeah, best of luck to everyone. And if you have any questions, I mean, you can ask me now before I jump off the call.
Yes, actually,
Alternatively,
Lilium has a question. How do you choose between methods to reduce the number of features?
yeah, you keep your what you're trying to find at the end. That's how I choose. There's many methods to choose from, right? But you have a output in mind that you are trying to optimize on, which is accuracy. So if you choose a method, and that's why this is always a very iterative process. There is no golden method. You probably have preferred methods, but there's no golden method. There's no golden standard in machine learning, and that's why it's always a very continuous and iterative process. And if you talk to any data scientist, they'd probably tell you there's 100 ways to do a problem and 100 ways to resolve the same problem. So you're trying to optimize on accuracy. Apply one method, see what results it gives you, and then if it doesn't give you a good method when you upload it onto Kaggle, do it again in a different method and see if that improves the results, and you start eliminating popular methods that way, right? So that's how I would approach that.
Excellent. Anybody else has any questions for Kevin before he jumps off the call? I mean, he gave us a wealth of information there, but just remember, as he said in the end, you're not reinventing anything at this point unless you really want to, for some of you who are more advanced. Anybody else wants to jump in with a question, either in the chat or on the mic for Kevin, based on what he said? I know that was a lot of technical talk, but I'm sure you'll have some questions moving forward, and yeah, Shankar has a question.
Resources or I guess sorry, any resources or guides you could provide to start learning about advanced time series methods beyond what's normally provided, like a GARCH and those methods and things like STMs and RNNs, and also to follow up, is there any like resources you could suggest for physics-informed machine learning, like any toolboxes that simplify the method, or books that assist in starting learning it?
Yeah, unfortunately, physics is not my realm of knowledge. So I would say I probably would have to do the same level of research into that aspect. But yeah, I will send Letitia some useful guides from all the way from introductory to advanced ML techniques that you could that would be useful for this specific problem, which is climate change, which we've explored before, right? So I will share some literature around that for you guys. Probably you'll get it before the weekend is over.
Great, great. And Liam has one more question before you jump off. Kevin, when to stop? When to stop, or is it when to know, Liam? Lilium, sorry. When to stop deleting features or records?
Sorry, sorry, I didn't write it correctly. What I wanted to say is that when do you stop to when do you know when to stop when you're like deleting features or records just to avoid like overfitting the data to your model?
Yeah, when you start getting too happy with the accuracy level, when you start getting this false perspective that, hey, my model is really accurate, I would say
I think
Did we lose
he's
him?
muted.
I wonder if he got
I think so.
Okay, but I know he was going to say when you're getting too happy with the accuracy, then you would realize that you actually, because that actually happened to us last year, where, as he mentioned before, one of our teammates deleted too many records and it was looking almost perfect, but then we realized it was too much. So it's really to leverage depending on the data set. And that's why it's so important to do the domain knowledge, as he was talking about initially, with understanding what the variables are doing in the model. Because even though it's a competition, you know, we would tend to say, okay, we're just doing this for competition. But if you were to come into this in terms of like the job space, you would have to ensure that it's really towards what the problem is. And because you could delete variables that are important. I think, Kevin, you were able to come back on. I don't know if he's hearing us. He probably got bumped up there.
Yes, yeah, I apologize for that.
No, that's okay. Go ahead.
Yeah, so deleting records is different from deleting variables, right? And I would never, obviously don't delete variables, you just remove them from your data frame, and different outputs, you know, suggest different levels of accuracy, right? So in some algorithms, you know, you will see one variable being an important feature, and in other ones it would not be, right? So there's different, I think ICE is a popular one for determining feature importance at the end of a modeling. That's just one of them. Shapley is another. You find a few of them that are popular for determining feature importance post modeling, right? But in terms of record deletion, I would say, yeah, it's generally it's not like, it's like a rule of thumb. Like I suggested, 10% is enough, right? For like, you know, and obviously that depends on how much records you have. I think you guys have at about 700,000 rows at your disposal. So if you start to delete beyond 70,000, you're probably deleting too much, right? You're going to change the perspective of the data frame. So I would say just be cautious with that. There is no like, there's too much, because if your entire data set seems to be very anomalistic in nature, then it's, in a sense, it's normal, right? Anomalistic behavior then becomes normal. But if you have some variables that, you know, have very weird values, remember, this is programmatic, right? This information is probably being collected via sensors, and sensors could go wrong. So I would say, you know, take those things with a grain of salt when you remove them. If you see a temperature on one day, for example, beyond 60 degrees Celsius, you could start to think, well, that probably is like an error. So I would say, you know, look at things like max and mins, and look at the counts of max and mins, and you could start to see things like that, Lilium. So there is no, like most things in data science, there is no right or wrong. Well, there definitely is a wrong, right? When you start removing too much records, but there definitely is no methodical approach to it. It's really sensitive to what you remove and how it influences your results. And like I said, the best way to validate that is when you upload your sample solution, that is the output that you've determined, you would see whether it was a good representation or not.
Hopefully that answers the question, Lydia.
Thank you. Yeah, thank you.
And we have one more question from Anisha in the chat. She says, I know there are many different types of prediction models out there. So it's a matter of trial and error to get the best model to suit your data set then? Or are there clues in a data set that can help guide which is the better model to use or try?
Yeah, sometimes they give you clues in the output itself, I would say. But I would suggest that you guys just start with like I said, there are different things. Most of the popular algorithms, they would give you a result. And when you start getting good results coupled together, you can start boosting them or ensembling them, right? So I would say, you know, at your disposal for this kind of problem, you're going to get like about 8 to 10 popular algorithms that you can use and explore. And then there are going to be variations of those algorithms. And then there's different boosting and ensembling methods that you can use based on the results you start getting, right? So, and then actually, when you start with your top algorithms, you'll actually see the pros and cons of working with each one of them, right? So like data with like a lot of diversity in it, decision trees tend to work well. Data that is strongly linearly correlated, you're going to see like your different types of regression models working very well. So yeah, they tend to give you that, but you have to do some level of exploratory data analysis to understand what variables are working in what way. And then when you actually just start to plug in your algorithms, they themselves try to, like, they actually let you know about what kind of data you have. It starts pointing back in the direction that you may have understood it to be before, right? Like the diversity, the number of variables, the number of records, and things like that. So yeah, there's about 8 to 10 algorithms that you guys can start exploring offhand. And then, like I said, just start seeing which ones work well and then improving those. Any algorithm that is performing very badly, I would just say, immediately just start to drop them so that you're not too focused, you're not too hyper focused on an algorithm, but you're focused on the output, right? So I would suggest that.
Great. Thank you so much, Kevin. And remember, you will also have those RMSE scores and the metrics to guide you with respect to the algorithm. So you will know which ones working well, as Kevin mentioned, and which ones you should try to, leave on the back end. We probably have one more, any more burning questions? Because I think we up for time in terms of Kevin's portion before we jump into the breakout room.
Not a question, but like add on to one of the things Kevin said earlier. I just want to get his take if this is a good idea. Recently I did a study where I was in load forecasting, right? And one of the methods, if you had scarce data, was to use data augmentation. And I was thinking that if you wanted to assess model accuracy, right, and you didn't want to overfit, what you could do is you could keep a very, very small segment of augmented data from your original data set, and then use that to compare your top, let's say, 5 models in terms of information criteria. And I think that could be a easy way to test the data. Kevin, do you think that makes sense?
It makes sense if you don't have validation results, right? But because you have a method to upload it on Kaggle to actually validate your results, yeah. But if it was like a problem where there is no real world results, then yeah, that's a really good. Creating synthetic data is always good when you want to compare results, right? Oversampling and undersampling techniques, or some kind of hybrid smooth technique, right? So I would say, yeah, it's good when you don't have a real way to validate, but you do have a real way to validate. In this case, it's Kaggle. Kaggle is going to validate and tell you, hey, it's good or it's bad, right? The WiDS people have already put together what they expect the output to be for this specific competition. So yeah, it can work definitely. But I would suggest that you just use Kaggle's resources, which is to upload the data, test it, and get a result, and you know what you're working towards and what you can optimize.
All right, thanks.
Okay, thank you so much, Kevin. We're really, really happy that you were able to answer these questions. If you all have any other questions, feel free to reach out to us, and we will let Kevin know, and he'll provide those resources. So thank you, Kevin. I'm giving you a virtual clap for all the support and the consultations you gave us today, right? And
no problem at all.
At this point, what we're going to do here is I'm just going to share the results of the poll, and then I'm going to put you all in some breakout rooms, so that we will just have about 10 minutes to get to know. I'm just going to put you into 2 breakout groups because I think in terms of the number of male to female ratio, I kind of just want you all to kind of do a quick chat with each other. This is the results of the poll, if you all are seeing it here. So we have about 9 or 69% of persons, I don't know if people change their answers or more people came in, said that they have registered to participate, and then we have some people said no so far, and then some people said they're not sure. So hopefully we'll help you all along in that regard. Let me stop sharing now, and Rihanna is going to share with you a link in the chat. So it's a participant skill sheet. So open that in the meantime. I'm just going to open the room. So you'll have 10 minutes. What I want you all to do is to kind of get to know each other. You may not necessarily be in a team with these specific people, but we don't have all our mentors here today. So I didn't want to put you all in different groups without a mentor to actually guide you. So we will have you in groups with the mentors who are available right now, and you all will discuss and just talk about your backgrounds and fill out the sheet. So click on the sheet, and I'm going to open the rooms, and you all have 10 minutes, and then we'll just come back in for some last words before we end off. So I'm going to open all the rooms now so you all can join. Okay, so I see we have everyone back in the main room. And at this point, this is the end of the session today. I just wanted to make sure that everyone filled out the form. I was just jumped in a breakout room and I realized that some persons would already have targeted individuals who they have on their team. So you could always let us know in the form, so we don't have to place you. If you want to work in groups of 2, that's fine, or groups of 3 to 4, it doesn't have to be 4. But in our end, we'll probably try to keep it at 4 to try to space out everybody. So once you all filled out the form for us, we'll have a look and we'll contact you all this week and tell you all which groups you're placed in with which mentors. So anybody has any closing questions or any queries, any comments, just to remind everyone to fill out the registration form, the official WiDS registration form on their page. And by Monday, you should hear from us regarding which teams, for those of you who are not on a team already, for those of you who are working with someone, just remember the other person has to be registered. And there will be a part of the page that you will see where you could actually have your team registered. You don't have to do it yet. They will prompt you by the middle of February to actually put who your team members are. When I was on the team, my team, we called ourselves, and you can come up with a fancy name. I was like, we call ourselves the WiDSards, WiDSards. So you could come up with a fancy name, and then eventually you could actually put that you could have your teammates there, right? So Shankar said he put his email here. If you have any questions, he may answer it. Yeah, so feel free to reach out. If you don't use Slack, email us at the WiDS email address as well if you want to reach out, and we could always have our mentors reach out to you. If they don't want to use their personal emails, they might answer you from there, or they can also reach you personally. But from my end, I would like to really thank you all for being a part of this experience. We're really happy to have you all on board. Just remember, you don't have to have all the technical skills. So those of you who just really want to dabble in it, help with the research aspects, that is fine. We're here to help, and feel free to let your peers know the community is not just for the challenge. We really want persons to come on board. We're building a repository and a GitHub page to have a lot of resources for you available even after the competition. And feel free to visit our website to register for the other talks coming up. I think they'll be very fruitful for you all. So the next 3 talks in February on the next 3 Saturdays will really help you and the mentors with the rest of the aspects for the competition. Any last words from the mentors before we go? Shankar mentioned, yes, we have an industry professional here, Anisha, right? So she works at Coastal Dynamics, and she also does some modeling aspects. So it's really nice to have persons who actually involved in the industry. Kevin as well. Kevin works in, I don't know if he mentioned, he works in PricewaterhouseCoopers. And we also have a few other persons who are not here today, Mercedes, Mindy, and a few of them involved in different data science related fields. So it's nice to have the interplay between academic and industry. So yes, so that's it from me. Mentors, you all have anything else to say before we close off on this session?
Yes,
Nicola,
good luck with everybody and have fun.
Be careful and try not to don't compare yourself against anybody. You see all those leaderboards with extremely high scores. It's easy to fall into feeling like you're not making any progress. It's a very slow path, especially when you're a novice, and it is a wide set of research that we have to be doing. So take your time, pace yourself, and just remember there are many more opportunities to come. This is just one of many, and don't be overwhelmed. Slow and easy wins the race.
Very good, very good. Rihanna, any last words?
I think it's just echoing the same thing. So good luck, and I hope you all have fun. And if you all have any questions or concerns, y'all could feel free to email us.
Yes, and Rihanna is very efficient, so she'll answer any of your questions and direct you to who you need to be directed to, right? So that's it. Thank you very much for sharing your Saturday with us. You all have an enjoyable day. Be safe, and we will keep in contact with you for the journey. And we look forward to having you all on the leaderboard. So stay safe and take care.
Thank you.
Thank you very much, Dr. Addison. Have a good day.
No problem at all. You all take care and have a great day. You're welcome, William, Nabil, Shankar.